So next we're going to look at the function f of x equals the absolute value of x divided by x. And we also have our graph to accompany that. And so let's see what the limit would be as x approaches 0 from the right side. Because as you'll notice, if you look at the function, we kind of have this weird gap going on at x equals 0. Down here we're at -1, but we jump back up to 1 when we start going into the positive direction. So let's see what happens as we find our limit as x approaches 0 from the right side. So we'll start on the rightmost side of our function, and we'll follow the function all the way until we get to x equals 0, in which we find ourselves at the y equals 1 value. So that would be 1. And then we want to know what is the limit as x approaches 0 from the left side. And we'll do that. We start from the left side of the function and we follow it all the way over. And once again, or not once again, it's actually a different value this time, we find ourselves at y equals -1. So now what happens when we want to look at both sides? This is where things get a little bit different. The limit as x approaches 0 from both sides can't be one of these two numbers because they're both different, right? So the limit as x approaches 0 from both sides of the equation is going to be a little tricky this time around because from the right side, it's 1, but from the left side, it's -1. So what do we do about this? Well, we can't say it's 1 because it's not 1 from the left side, and we can't say it's -1 because it's not -1 from the right side. So we just simply don't have a limit here, and we have to say that the limit doesn't exist at 0. So we write this by saying DNE, which stands for does not exist. So in this case, the limit doesn't exist because the limit from the right side is different from the limit from the left side.